Greetings and salutations, magical chemists. Let's talk about dilutions and how it affects pH. A dilution, of course, is when you're adding water to a concentrated solution to decrease the molarity. Now, a stock solution is a concentrated solution. It's what labs purchase to save time and space in a lab. What you do is add pure water to the stock solution to achieve your desired molarity. When you're diluting a solution with pure water, it's important to remember that the number of moles of the solute do not change. The dilution equation is a handy equation we can use if you know your initial molarity and the molarity you want, and you know your starting volume. You can calculate the new volume you need. One of the best parts about this equation is you can use either milliliters or liters for the volume, as long as you're consistent on both sides. When you're diluting acidic and basic solutions, it's very important to be able to do simple estimations without a calculator. For instance, if you double the volume of your solution, which means you're adding an amount of distilled water that's equal to the original volume of solution, well, that will decrease the concentration by half. Another common one you want to recognize on site is when you're increasing the volume of solution by adding 9 parts distilled water to 1 part of the original solution. You might be thinking that's a really weird, like 9 to 1. Wait, but why? Well, here's the thing. If you add 9 parts to the 1 part you have 10 parts. You've just decreased the concentration by a factor of 10, because the volume is 10 times bigger than what you started with. Okay, we're going to try a couple of practice problems, and even though they're free response, we are not going to use our calculator, because that's the most common type of problem you'll see, is a multiple choice problem with these calculations. Okay, in our first problem, we have 200 mils of 0.2 molar hydrobromic acid, and we're going to add 200 mils of distilled water. So we're adding a volume of water equal to what we started with. So hopefully you remember that that means the concentration must be half of what we started with. But let's prove it by looking at the dilution equation so you can see where the math is coming from, and thus hopefully it'll be easier to remember. So I'm just going to plug my initial concentration and my starting and ending volumes into the dilution equation. Notice that my final volume had to be the sum of both of my initial volumes. Well, the initial volume of the stuff plus the volume of the water. And then it's just math. Rearranging for our unknown molarity, we get 0.2 times 200 divided by 400. And hey, just like we predicted, that's 0.2 times 1/2. Next, it asks us to find the pH of this new diluted solution. Well, conveniently enough, hydrobromic acid is one of our strong acids. That means that it will 100% dissociate. So we just can take its concentration and plug it in for the concentration of H+ for the negative log. Remember that you want to take that 0.1 molar and rewrite it in terms of scientific notation, because it makes it so much easier to figure out what the actual negative log of that will be. Remember, that only worked because it was a strong acid. If it was a weak acid, we'd have to take its concentration and plug it into a rice table and do all that fun calculation-y stuff. Wait, we haven't talked about that yet. Don't worry, we will. We will talk about how to calculate pH when you have a weak acid. That's coming up next. Okay, let's try one more. This time you have a 100 milliliter solution of 1 molar lithium hydroxide, and you've added 900 milliliters of distilled water. Well, did you notice this is that adding 9 parts to the 1 part? So hopefully you remember that that means the concentration will decrease by a factor of 10, but let's prove it using, of course, the dilution equation. Notice that our final volume is 1,000 milliliters because we added 100 mils to 900 mils. And then, of course, next comes algebra. And so we have 1 times 100 divided by 1,000, which is 1 times 1/10. And of course, we want to find the pH of the new solution. But this is lithium hydroxide. Now, it is a strong base. However, it's a base, which means when we take the negative log of its concentration, we're going to get the POH, which we then have to convert into pH. Once we find the POH, then we can subtract from 14 to find pH. So in this case, we've got a pretty basic solution with a pH of 13.00. And there you have it, dilution calculations without a calculator. So thank you for playing with the glories of chemistry.